About $185. That is what it costs to let an AI write the code, review its own work, and carry it through deploy with nobody at the keyboard, 5 runs. About 45.5 hours, just under 2 days. A real API service shipped, and whether you can trust any of it comes down to 3 moments. 3 moments where the machine refused to trust itself. You have already run a coding agent on something real, not a toy. A task with a spec, a test suite, a deploy step, and you watched it drift. It declares the job done with half the work missing. It writes a test that asserts nothing, then reports it green. It edits the one file you told it never to touch. The problem is not that the model is dumb. The problem is that it is confident. It reports success in the same flat tone, whether it succeeded or not. So you babysit it, you read every diff, you never walk away, because the moment you walk away is the moment it ships something wrong and swears it went fine. And that is the real fear with unattended work. It is not a reasoning failure, it is a judgment failure. The agent's judgment about its own output. A human engineer knows when they are unsure, they slow down, they ask. An agent does not slow down. It hits a wall and reports a clean pass anyway. So the interesting question was never whether an agent can write code. Of course it can. The question is this: what would have to be true before you would let one write, review, and ship while you were asleep? Here is the machine that tried to earn that answer. It starts with one file, a ticket in plain language. Build this service. Meet these acceptance criteria. Done means all of them, not some. Then you walk away. What runs is a single bash loop, and inside that loop lives an entire engineering organization, 12 specialized sub-agents, each with one narrow job: a spec writer, an architect, a data architect, a builder, a reviewer, a tester. None of them are people. The loop walks a fixed chain of 9 phases: spec, then architecture, then the data model, then the build loop where the code gets written, then 3 checks, end-to-end security and hardening, then documentation, then deploy. Nobody picks the next step by feel. The order is fixed in advance. Between every phase, the loop writes a small file to disk and reads it back before moving on. No phase advances on a hunch. It advances because the phase before it wrote down in that file that it passed, and the rule is fail closed. If a phase does not write a clean pass, the loop does not guess and continue. It stops. Silence is treated as failure, never as success. That one rule is what keeps a stuck agent from quietly declaring victory. The file, phase to phase, is the only thing the loop trusts. Not the agent's word for it, the file. The 3 checks in the middle are the whole point. They are gates, and they have teeth. The build loop does not get to decide it is finished. The end-to-end gate reruns the entire definition of done. The security gate hunts for the bad thing that passing tests never reveal. The hardening gate checks that the deploy will not detonate. Any one of them can say no. When a gate says no, the run does not fail. The gate writes down exactly what is missing and kicks the work back to the build loop. Then it runs again from a clean slate, refusing to trust last round's result, and there is a hard bound. Too many kickbacks, and the loop halts and pages a human. That is the line between looping forever and stopping for a person. The machine is engineered to distrust itself. That is the only reason it can run unattended. So does any of this actually work? It ran on a single server 5 times across about 45.5 hours. It took a real API service from an empty folder to a shipped build, essentially every line written by the agent, not a person. The total recorded cost was about $185, and 2 of those runs were clean, full build completions, one at $60.87, one at $82.05. Those 2 were not the same build twice. One built the shared core of the service, the other built a feature on top of it on a frozen core the agent was not allowed to touch. None of that is estimated. Every figure comes from a log the pipeline writes on every run. That log is the reason this channel exists. Here is how much the environment matters. The very first run cost nothing, $0. It died in 12 minutes at a permission dialog. The agent launched with nobody there. It hit a prompt asking whether to trust the files in its own folder, and there was no one to answer it. Think about that. Before you can trust the agent with production, you have to trust it with a directory. And even that took a single configuration flag set correctly before the machine could touch its own workspace. The expensive-looking failures in autonomous work are usually the cheap ones. They live in your setup, not your model. Now, the 3 moments the machine refused itself. First, the Completeness Ratchet. Across 3 separate builds, the end-to-end gate blocked the work 4 times, then once, then twice. Every single block was missing scope, never a bug the agent had introduced. The test suite was green while whole files did not exist yet. The gate demanded the entire definition of done and refused to advance on a green subset. Second, a reviewer with no shell waved through a one-line change. It looked trivial, but it broke a frozen test, and the reviewer had only read the files. It never ran them. The tester who could actually run the suite caught it. One test failed. 165 passed. The fix went in, and the loop wrote itself a rule. Never let the agent that cannot run the code have the last word. Third, the security gate refused an all-green build over two high-severity findings. Neither was a bug a test suite could see. One let the authentication quietly fail open, so every request succeeded, which was exactly the problem. The other was a network trick that looks perfectly honest on the first lookup. Only a gate that goes hunting for the missing safeguard ever finds them. It held the line until both were fixed, then re-verified them live. 166 tests passing, 0 critical, 0 high. A gate that always says yes is not a gate. Every one of these said no. And none of this was clean. 7 distinct failure events got logged along the way, a trust dialog that stalled at startup, a background task killed at 600 seconds, a cost ceiling that did not hold on resume, all 7 recorded, none of them hidden. That is the difference between a receipt and a demo. A demo shows you the one run that worked. A receipt shows you all 5. One video cannot open all of that up, so this is the map. Next, we open the ledger, what $185 actually buys, and exactly where the money leaks. Then my favorite bug, a cost ceiling that halted the run and paged a human at 40 past midnight. It had run past its $25 limit to nearly 30, then forgot that limit the second the agent resumed. One guard moved to the right place, fixed it. After that, the gate chain in full, how a loop is built to reject its own work, then the setup that makes a headless run repeatable, the security teardown live, and the negative results, the runs that failed, and a project that proved rigorously that it could not make money. Everyone is a receipt, not a claim. So, the honest answer to the question I opened with, would I let an agent write, review, and ship it with nobody watching? Yes, but not because it is smart, only because it is built to refuse itself. You trust the scaffolding, not the model, the fixed chain of phases, the status files that will not lie, the 3 gates that can send the work back and cannot fake a pass, and the hard stop that ends in a human. That is the thesis of this channel. No hype, no demo magic. Just this machine taken apart one layer at a time, receipts on screen. The next video opens the ledger, subscribe, and you get every tier down. Every layer backed by a log you could audit yourself.